Hey everybody. So we're going to make a midterm review guide. I did one of these last year, but my knowledge of Python has substantially increased, so figured we might as well just make a new one. Plus, technically, it's slightly different than last year's anyway. I'm not going to spend forever rambling. We're just going to jump right into it. Although I will say, some of the stuff that I talk about might be a little bit more helpful if you watch some of my other videos, but whatever. It is what it is. Also, I'm going to be moving around a lot because I have a standing desk, so you'll see me just kind of moving around. I hope it's not too distracting. I'm just kind of, I can't really sit stable right now. I got too much physical energy here. Okay, so let's jump right into it. So we're just going to go through this like bullet by bullet, and then there's some text down here as well for topics that we'll go through. So we're just going to jump right into it though. So the first part here says we need to know how to define a function. Well, so in order to define a function, basically you have this part here, which this whole line is your function signature. This line number 10 here in my Python file. So I made a function here. This is my function, and I just called it example function. That's a terrible name. Please don't call your functions that. But anyway, this is my function signature line. And then this part right here, def, is how we tell Python we're going to make a function name, and it stands for define. So we're going to define a function. This part right here is the name of our function, and that's how we're going to have to use when we, that's what we're going to have to reference. It's kind of like a variable name. That's what we reference when we want to execute the following code in this block. This right here is our parameter, not to be confused with arguments. We'll go over that in a second. This is a variable that we defined within the function. Now, I want you guys to keep something in mind. I've talked about this before in my scope video. If you don't know what I'm talking about, please check out my video about scope and functions. It'll be very tremendously helpful for what I'm about to say. But this variable right here, int input int plus 5, is only defined within this function. So I can't access this variable in the global namespace, which is out here, like where random is. I can't say, for example, print input int plus 5. See, well, it helps if I actually use the exact variable name. See, Python is like, what the heck? This isn't defined. See, if I even hover over this, it'll say there's not, like, it doesn't, it's not defined. It doesn't know what I'm talking about. But if I just move that line of code right in here, no problems there. We're good. So that's what I wanted to talk about scope. So there's a thing in there's a thing in Python called scope. Sorry, I didn't mean to hit the mic there. There's a thing in Python called scope, and basically you have to know that your functions have their own kind of like variable namespace. And what I wanted to show you also is, notice I use the same parameter name in this function, and this function, and this function, but notice they all highlight different things because they're all different variables. Like, even though they have the same names, this, when I say string to traverse here, it's only talking about this string to traverse. It's not talking about the one down here. It's not talking about the one down here. See, they're kind of like in their own islands. So even though you can see all these functions with your own eyes, Python kind of treats it like it can only see this one, and then it can only see this one. Like, once it's inside of a function, it kind of moves into its own little island, you know? It's kind of like, it's like literally walking inside of a building. It's like, you know, there's a world outside around you, but for now you can really only see like the walls of the building. You know what I mean? So it's kind of like when you're executing your functions, or at least when Python is, it's kind of like walking into a new building. As soon as it executes this function, it kind of walks into a building and it says, oh, okay, there's a variable here, and it equals our input variable that we had. And this brings me to the last point of functions, returns. Returns are kind of like your exits out of a function, because if you think about it like a building, you know, it's kind of weird to say, because when we think of a building, I mean, I think of a doorway. I can walk into a doorway and I can go into a building, and then I can walk right back out that doorway. But Python, it's kind of like every door is a one-way door. So it's like the inputs here, like my parameter here, is kind of like, and when I call the function, it's kind of like, analogy-wise, it's kind of like when I call the function, I'm kind of like opening the door to the building. And I'm saying, okay, Python, I want you to step into my building here, and I want you to bring that piece of data with you, which is the parameter, which when they call the function, they'll use the argument, but we'll get to that in a second. And when they use the argument, they're going to give us that data, and I'm going to say, okay, we're going to modify this data when you get in here, and then when you leave, I want you to use that door instead. You can't use this one. You have to use the one over there. So that's kind of like functions in an analogous sort of way. So returns, what returns do is they do two things in this context. One, they provide an exit. So your function, when it hits this, when it hits this return, your function will stop executing. The other way your function will stop executing is if there wasn't a return, but it did all the code in your function. Like, let's say I execute this function, it'll do this, and then we never do anything with this variable because we don't return it or anything. So it's like, okay, we have this variable, we stored it in memory, and now it's gone. We don't care anymore. So it would have returned. But the thing is, this is also something that I talked about before, that, again, I've talked about this before, but I don't want to overload you guys too much. But just remember, real quick, remember, if you don't write a return statement in your functions will always return something. What will they return? None. All of your functions return none without you ever having to type it, unless the function hit a return statement like the one we had a second ago. Oh, that's not the return. Well, I copied the wrong thing. That's definitely not a return. We'll get to that in a minute, though. Yeah, if it hits this, it won't return none. It'll return whatever you told it to return. But if you don't ever put a return statement, or if you do literally say return none, in both cases, it will return none. But note that every single function, regardless of whether you type return anywhere, will always return something. It always returns something. Sometimes I see people say, this function doesn't return anything because it returns none. And I'm like, that's not how that works. That's not what return none means. None is still a valid bit of data. It's like the null concept. You know, it's like if I asked you what the color of your unicorn is, you would say, that doesn't make sense. I don't have a unicorn. So it's not black. It's not white. It's not really any valid color because I don't have a unicorn. So the answer to that question is null or none. Sometimes it's labeled differently in different programming languages. Python likes to be fancy and use the word none for common folk language, but the kind of concept kind of stems from null, which is like a general computer science thing. But anyway, so every function returns none. So that's what you need to know about functions. This is how you make the function. You use this line. Well, not this exact line, but you would say def and then whatever your function name is, and then you put the parentheses, and then you put whatever your parameters are. And you can have multiple parameters. So you could say input int1, input int2, and so on and so forth. But whoops, I want to redo that. So you could have multiple parameters, and that's all I'm going to really talk about functions, because I could honestly spend another like 45 minutes talking about functions, but we don't need to cover all that. So I do want to talk about how to call the function, though. So that's how you make the function. Now, actually, there is one more thing I need to talk about when it comes to making the functions. So this gets complicated, and I'm not going to waste your guys' time too much spending 40 minutes talking just about functions and not about anything else. But remember, one really important thing, I believe I've talked about this before, but one really important thing that you need to know about functions is when you reference a parameter variable in your function, Python doesn't necessarily know what's valid and what's not valid for that data type. For example, if I import turtle into my Python script, then I could import turtle here, and we can make a quick turtle function, and we could say def move forward by length int, okay? And then I could say turtle object, and then we could say turtle object dot forward by, oh, let's give it another parameter and say length int. And this will be an integer. So it'd be like 100 or something, for example. So, okay, so now I have this function. And the thing is, here's the thing. Python doesn't know that I'm referencing a turtle.turtle object. When I say turtle object, what I mean is we expect the user to pass in some kind of object that looks kind of like this. Like, say, Kevin is equal to this. And then when you call this function, you would do something like this, which gets into the part I was going to say about calling functions. You would pass in the actual information. And then that's a perfectly valid function. We could execute just this code alone and it would do it. Matter of fact, let's just go ahead and do that. So if it's also going to execute some other stuff that I had down there, but you can ignore that. So give it a second. Hang on. Yeah, and it moved forward, and then it killed it because I didn't have like an exit on click thing or anything. But still, like, that was a perfectly valid function. But here's the thing. Here's what I wanted to highlight. Notice here we use the actual variable Kevin. Kevin is a real turtle object. We just saw that. Kevin is a legit turtle object that we have created. And here, when we call the function, that's when we actually pass in the real object. That's when we pass in the real thing, okay? Like here for 100, that's when we passed in the real number that we want Kevin to move. We wanted him to move 100, but I could have called it with 500. I could have called it with 1,000. Doesn't matter. Well, there probably is actual limitations, but you know what I mean. But here, notice in the definition of the function, when we're defining the function, we can use generic terms. As long as we're referencing something. You can't just make up things. You have to reference something that exists. So you have to either make a variable and then reference it, or you have to reference your parameter variables, which in this case are the turtle object and the length integer. Okay, so don't get too caught up in all the little crazy terminology. Just focus on what I'm saying. So here, notice, what I wanted you to notice is this turtle object here. This is just a generic term. See, even Python's saying it's just a parameter, and its object type is any. We don't know what kind of data type you're talking about here. But notice we're not getting an error here. Like, even though Python doesn't know what kind of data this is, Python's still like, okay, whatever it is, it has the forward method. It can move forward, I guess. Okay, sure. But here's the thing. If I try to call this function, and let's say I get my parameters mixed up, and let's say we do the same thing, but we do 100 and then Kevin, well, now Python's really going to yell at us. So watch what happens. We're going to make Python really mad here. It's going to be kind of funny. So let's let Python do its thing. Ah, here we go. Look at that. Error. We already got an error. So it's saying that the integer object has no attribute forward. So the reason that failed is because what Python actually did when we tried to execute that line, what Python actually did is it was basically going into the code, and it basically did this. It did 100.forward Kevin. That's what it was doing. Instead of Kevin.forward 100. Notice these are basically the same, just switched, and it breaks everything. And this is what I want you to know is, I don't care that you know about Turtle. What I want you to know, though, is that when you're writing your functions, Python is assuming that things will work. It doesn't know. It assumes. There are some things that it knows, but that's only with the built-in data types. But if you're using other libraries like random, math, int, stuff like that, it just has to assume things. So, you know, sometimes I see people say, like, for example, here, when we did the, like, for example, we're adding 5 to a number. Okay, but what is the number? Because we never defined a number. And I see this a lot with people beginning in Python. They're like, I don't understand why I can write this function and nothing goes wrong. Because it's like, I'm not actually giving it a number. I don't understand. Like, adding 5 to what? And people don't realize it's okay. This is totally fine. Because Python knows that when we, well, it doesn't really know, but it hopes that when we call this example function here, we're going to pass in an actual number, and then we would return, and that would give us 5. Okay, last thing I'm going to talk about functions, and then I swear to God we're going to move on. Okay, let me delete all this turtle code because it's kind of irrelevant to what I was really going to be talking about in this video. But I just wanted to highlight that. So last thing I want to talk about, and then I'm done, I swear to God. So functions. Okay, last thing. When you return something, I never said the second thing that returns do. I just realized I went on this really long tangent. The second thing that returns do is when you return anything. In this example, we're calling the function with 5. So forget about returns for just 1 second. Let's see what happens when we call this function with 5. So we call this function with 5. We say input integer is plus 5 is going to be equal to whatever the input integer was plus 5. That's a pretty good variable name. It's a bit wordy, but it's a pretty good variable name because that's literally exactly what it is. So we're going to return whatever that was. Now, I think I passed kindergarten, but let's do our hand counting for a minute here. 1, 2, 3, 4, 5. Okay, we got 5 sheep over here, plus another 5. So 1, 2, 3, 4, 5. Okay, so let's do that all together now. 1, 2, 3, 4, 5. Whoops, went too fast. 6, 7, 8, 9, 10. Okay, good. I passed kindergarten. So that's supposed to be 10. Okay, so, yeah, sorry. So, when you return a function, when you return something from a function, what you're actually doing is, now that we know what this value is going to be, what we're actually doing is we're going to set this entire function call, this block of code that I highlighted, we're going to set that equal to whatever this was. So if I set this to a variable and I say output integer is going to be equal to that, then I know that if I were to print output integer, it would be 10. I know because I went to kindergarten, and unless the rules of math suddenly change between now and when I click the play button, it should print out 10. And I'm not going to do it because I had a lot of crap that I was also printing, so we'll just kind of ignore it for now. But basically, you would know that if you want to try it, for example, and I can show this later on as we go in the video, but if you want to try it, you know, just to test yourself to see if you really went through kindergarten and you passed, there you go. But that's what returns actually do. The difference between printing something and returning something, which does come up later in the PDF, so I'm going to go ahead and cover it now while we're at it. The difference between printing something and returning something is that when I print something, it's only displaying it to the console. But that's it. And that's fine if that's what you wanted to do. But let's say I wanted to take this number 10 here, and I wanted to pass it into another function that I made that says, like, I don't know, let's say it squares the number. So now I started with 5, I go to 10, and then I go to 100. And I need to be able to pass that 10 to another function. I mean, sure, the code is simple enough. I could probably do it all in one function, sure. But when you get into like really complicated function design, you really need to be able to like take one thing from a function and put it into something else and then put it into something else. And it kind of becomes like this assembly line. And so like literally like an assembly line, when you think about it, I mean, you don't have one machine that does everything. That would be kind of silly. You make machines that are really, really efficient at doing one specific task or like a very small few of specific tasks, and you make them do their task and then you send it down the pipeline. And that's exactly what we're doing with our function design. That's why we use functions. And because they're more modular, because I could input, sure, I could say print 5 plus 5, and that's fine. But what if I want to do this 100 times? Wouldn't it be helpful if I just made a function that just takes whatever number, no matter what it is, and add 5 to it, and then I can just run it through a loop or something like 100 times? I mean, that way we can just call the function instead of saying do this plus 5, like, you know, or I don't have to write like print 5 plus 5, print 6 plus 5, print 7 plus 5, like a million times in my code. That would be ridiculous. So, you know, that's one of the reasons why it helps to have functions, because it makes things more modular. Okay, moving on. Let's move on. So, we're not going to talk about functions anymore. We're going to go ahead and move on to the next stuff. And I know this is like, bro, this video is already 18 minutes long. We've only covered one bullet point. Trust me, we're already like halfway done. You don't even understand. We just covered so much stuff on the midterm. You have no idea. So we're going to quickly kind of cover some other stuff here. So the next thing was we called the function, used the return value. We just went over that too. For loops and while loops. Okay. So based on what I'm seeing in the PDF, there's different parts of this. We don't need to know traverse by element, but I'm going to go ahead and cover it real quick, and then we're going to move on. But we do need to know building a string, traversing by index, accumulating a sum, and to convert between the two if possible. Okay, forget about all the syntax. Let's talk about something more conceptual for a second. So for loops and while loops, they're ways to like repeat the block of code underneath your loop. So for example, here, we're only doing one thing underneath the block. So in here we say for something in something else, do stuff. And the stuff in this case is going to be done X amount of times, where X is the number of things in the something else item. So for example here, in our traverse by element function that I made here, basically what's going to happen is if I call this function and I pass in a word, like for example, word, a 4-letter word, what's going to happen is that for loop is going to fire off 4 times. It's going to go from the top here and it's going to say, okay, character is now W, so print W, and then character is now O, print O, character is now R, print R, character is now D, print D. And that's what it's going to do. But I could pass in any word I want into this, any string. It doesn't have to be a word. It could be a bunch of numbers. As long as it's a string itself, like as long as the data type is a string, or some kind of iterable even, then it can print anything in there. So basically, for loops are really good for if you're iterating through a specific like list of things or a thing that could be iterated through, which I feel like I didn't probably explain that as well as I could have. But we're going to stay conceptual here. While loops, on the other hand, this is the big difference. While loops are a little bit... So you can iterate through things with while loops. But where while loops really shine, and where I tend to use the most in my own code, personally, and where I see them used the most in other people's code, is while loops are better if you're going to do something like again and again, but you don't exactly know when you're going to stop. Like, for example... user input. If I ask you, do you want to play again? Yes or no? And you keep saying something else other than yes or no, that's fine. You're just wasting your own time. But we still need to keep asking you, do you want to play again? Yes or no? Yes or no? Yes or no? Yes or no? Even if you don't actually give us a proper answer, you could do that a million times. Doesn't matter. As long as the heat death of the universe doesn't happen, or a meteor hits the Earth, or the computer crashes, or whatever, you could theoretically keep doing this an infinite number of times. Well, maybe not infinite. I think eventually the program would probably run out of memory or something. But, yeah, theoretically, you could keep doing it an infinite number of times. We don't really know when you're going to actually say yes or no. So that's when a while loop is really, really helpful, because we want to keep doing this thing, and it's perfectly valid to keep doing this thing, but we just don't know exactly when. I'll give you a real world example of this. I had to write a program that iterated through a list of photos to post to Facebook. It was like a nature photo page, and I still moderate this page. I still have it. Like, it's still a real thing. But one of the things about it is it actually uses both a while loop and a for loop at the same time. It uses a loop inside of a loop. And it has to do that because basically the way it works is we start a while loop, and then when we start... Sorry, I just noticed my mic is clipping a little bit. I'm speaking a little too loud here. Let me lower my mic volume just a little bit for you guys. Okay, sorry. I think we're good. Let me lower it just a little bit more. Just a little bit more. Okay. There we go. I think that's better. All right. Sorry. I don't mean to yell in your guys' ear. Okay, so it has a while loop and a for loop. And the way it works is we have a while loop that says, okay, while we don't have a good photo to use, let's just keep iterating. And then we have a for loop. And the for loop gets like a page worth of photos. It's kind of like how Google used to work. I think Google nowadays, when you search an image on Google, it kind of like, you can kind of scroll forever. But like, you know, back in my day, kids, when you Googled a photo on Facebook or something, you would like scroll through like a whole bunch of photos, and then you'd have to click to the next page, and then you'd get to the next page of photos, and you'd scroll through all those. And that's essentially what the bot is doing. In that sense, it's not really like a constant stream. It's more like a block of photos that it has to look through. And then it checks certain criteria, like it hashes the image to see if we might have posted it before, but maybe it's a different post on the service that we're getting it from. It has to check like the file size, so it doesn't try to post a photo that's like 10 gigabytes in size to Facebook or something. And other little things like that. I'm not going to go into the whole thing about it, but that's an example though, because for loops were used to iterate through the list of photos on each page, but we never knew which page was going to give us the photo we needed. Sometimes we had to go through like 5 pages of photos to get a photo we either haven't posted before or isn't too big or isn't whatever. And so we had like a list of criteria, and so it was like we have this list of like 15 photos that we iterate through on each page. 15 photos, page 1, nope. Page 2, nope. Page 3, yep. And it's like gambling essentially, because you never know exactly when you're going to hit the jackpot on a photo that you need. Usually it doesn't take that long, but you still never know. That's why we have a while loop and a for loop. So the way it works is the for loop will iterate through a block of things, and then if it goes through the list and it says, okay, we still didn't find a photo, then it starts the while loop again and then goes into the for loop and says, okay, let's iterate through these 15 things, and then, okay, we didn't find anything, start the loop again from the while loop and then go into the for loop, and then, you know, so it just kind of like does the double loop thing. It gets kind of complicated in the real world with Python, as you'll soon realize, but I don't want you to be afraid of it, because it's really fun, and it's fun to do these things, and it's fun to watch your code do stuff for you. Like making that nature page, oh my god, it was so cool to see this page just automatically post nature photos for me, and they were beautiful photos. but I'm not going to talk about that. I could talk about that forever. It's so cool. Okay, so that's when to use while loops and when to use for loops. Just a quick note, while loops are good for if you don't know exactly when you're going to stop. For loops are good if you know, like, for example, you have a list of photos, for example, in that example, but let's say you don't get another page or whatever. Let's just say you always know there's only ever going to be 15 photos or less. You might find a photo halfway through, and that's good, but at most, you're only going to go through these 15 photos, and if it's not in the 15, whatever, just shut the program down. That would be a good example of a for loop in that specific instance because you're iterating through a specific list of things. Or if you have a list of numbers, or if you're going through data and you have to pull data from a file, unless the file is constantly changing, when you're getting the data, you're kind of getting it in chunks and you're just iterating through that data. So that's when you want to use for loops primarily in Python. Okay. So let's get back to the syntax. So this first function I made up here, not the first one technically, but this first one involving the for and while stuff, this is called traversing by element. And we don't need to know this for the midterm. So if you want, you can just kind of mentally shut off here and take a break for a moment while I talk about this. And then we'll talk about the index and stuff. But basically, this is called traversing by element. And it's saying for, you're basically, the syntax is basically for something in something else, print something. So this is called traversing by element, and the reason it's helpful is I use traversing by element a lot in my own personal programming because most of the time I don't need the index of the thing that I got it from. I just need the thing. Like, I'm just looking for the thing. I don't really need to know where it was. I need the thing. When I see the thing, I'm good, you know? So this is traversing by element. You're saying for everything in the item, let's just print the thing, basically. For I in range length thing, then this is traversing by index. So down here, I made a helpful function for you to kind of keep in mind. I'm going to space it out a little bit so you can kind of see a better thing visually here. So on the first line of our function, other than the definition, like other than the signature line, we say for I in range length string to traverse. So we're getting the length of the string. So again, let's use the example word here. Word is a 4-letter word. So this would be for I in range 4. So we're generating a range, which is basically just a list of numbers, 0, 1, 2, and 3. And we're saying on the first iteration, I is going to be 0. Then I is going to be 1. Then I is going to be 2. Then I is going to be 3. I know my hands don't really match up with the numbers I'm saying, but it's because I'm talking about the iteration, not the actual value of I. One cool thing that I didn't see a lot of people do in their homework, but I thought was really interesting to see every time I saw it, and something I wish more people knew about, is you can kind of turn an index loop into an element loop too, just by saying you can make a variable that represents whatever the thing is. So current character would be, okay, forget about loops for a minute. Let's talk about string indexing real quick, and then this will make more sense. If I have a string, let's say word, let's say example string is equal to word. Okay, let's say I have an integer variable, and let's define it so that Python isn't screaming at us. So if I say print example, whoops, helps if I can type, example string, I have too many example words, it's throwing off my type hinting here. If I say print example string I, what that means is, what I'm actually doing is I'm saying print example string 0, and what the brackets and the 0 represent is, it means we only want the first item in the string. And then 1 would be the second item in the string, because indexes start at 0. So I can get the first item, the second item, the third item, and the fourth item. So when I say for I in range length string, what I'm actually saying is for I in, where I represents each item in the thing that we're about to generate, we're generating a range, which is basically, you can think of it like a list of numbers. And the range, the range is from 0 to the length of the string. And this will always ensure that our range matches up with or that our index matches up with the thing that we're talking about. So we can say current character is equal to string to traverse I. Okay. Now we can reference both the character, both the character and the index at the same time, and it's really, really helpful. So let's go ahead and print that. And let's call this function. We didn't actually return it. We're just printing it. So let's call this function. And let's give it that example that I talked about, just so you guys can really see it with your own eyes. And I need to print, I need to clear any of these other functions. And then we'll talk about while loops, and then we'll talk about debugging and ifs, and then we're pretty much done. So this video will not be as long as you might think it will be. Okay, so let's go ahead. I don't really want to debug. I just want to run, because I just want to see all the outputs. So there we go. Right there. See? Now, this was our format right here. And these are F strings, by the way. If you've never used F strings, they're so helpful. They're so clean. They're so easy. Look how easy this is. You put an F, and then you type your string, and then anytime you need to put a variable in, you just put in these little brackets. Look how easy that is. So simple. Anyway, so, and by the way, these are two different kinds of variables. This is an integer variable. You can see it right there. It's an integer. And this is a string. Well, it doesn't know it's a string because we haven't, like, told it. But if we told it this, if we added more type hinting to our function, and we define that as a string, and then we define this as a string, because this is always going to be a string, then it'll know that this is going to be a string, because we added type hinting. Some things Python knows, some things Python doesn't really know. Sometimes you have to tell it. Doesn't matter, it still would have worked regardless. You can see it right there, it worked. It's just, I like to show you visually what I mean. But notice these are two different kinds of variables. So if I were to concatenate this, I would have had to convert I to a string in order to concatenate this into a string. But with F strings, nope. Just little brackets, and then there you go. Pretty easy. Anyway, but you can see it printed I, which was the index on the string. And then it printed the arrow. I highlighted all of that. I didn't mean to. This was I, this little 0 here. It printed the arrow and the space. The space is included in the string. And then it printed the character, which was W. And it did this 4 times. And every time I changed. And because I changed, then the character changed too. Because notice, this was static. Remember when we called the function, we called it with word. So this variable never actually changes in the entire time of our function. However, because we're indexing it, the index part of the variable does change, because the I is what changes here every time. Now, I could have just said 0, and then I could have just printed it, and it just would have printed this line like 4 times. But because we used a value that actually changes, we used I, then therefore our output string will change. Okay, anyway, that's also string indexing. We've now just covered another thing. Very simple, very easy to talk about. Let's go ahead and remove some of these blank lines here so we can make our file a little bit smaller visually. And we'll remove our traverse by index example there. So now let's talk about while loops with traversing by index. It's basically the exact same code. Literally right here, same exact code. These 2 lines, I'm not even joking, I just copied and pasted these. Like, well, not this, but just these 2. I literally copied and pasted because it's the exact same code. The only difference with while loops is we need to define some condition for the while loop to stop. So the syntax for while loops is while condition, then do this thing. And this has to be true or the while loop will never fire off. And if this ever becomes not true, then the while loop will stop. So what I want you guys to realize is when you're running your functions, Python will actually execute this line first, obviously, before it does the loop. I mean, not first in the function, but when it gets to this line, it will execute it, and then it will do the stuff in your loop like you're probably thinking. But what you may not realize is, let's say it gets to this line, the I+1 line. When it executes this line, the next line it's going to execute is not this. That's not the next line it executes. The next line it executes is this, because it's going to go back and say, okay, we did all this block of code. Is this still true? Okay, it's still true. Let's keep going. And it's going to do the same thing 4 times. And the only difference here is that we had to make our own exit condition. Here, the range thing kind of takes care of it for us with the for loop. And for loops kind of already have their own built-in end. You can put a return, you can put other stuff in there to make it stop, like a break or whatever. But if you never put a break or return, you're not going to get an infinite loop. Eventually, it will end when it reaches the end of whatever the thing is that it's iterating through. In this case, it's a range from 0 to 4, which is basically like, I know I keep saying it's a list. It's not technically a list, but just kind of bear with me here conceptually. You can think of it like a list of numbers where it's like 0, 1, 2, 3, and then it would end there if the word was 4, or if the length of the word was 4. Then it would end there. So you literally just have 0, 1, 2, 3. So it has to go through all that. But once it gets to 3 and it does 3, done. While loops, on the other hand, this could theoretically keep going forever if I didn't set this condition. I could just say while true, and then it'll just go forever. So that's why we did I equals 0. So we had to initiate our own variable here. And then here we have to add 1 to I to actually make sure that this works. If we didn't do this line, it would just print forever. But we have to make sure that we're actually increasing I. So I want you guys to know that when you're using while loops, yes, it does go back to the first line every single time, and it will check if it's true. That's how it knows when to exit and when not to exit. One quick thing about while loops and for loops, and then we'll kind of move on. You can use a break statement to return, or sorry, I'm using the wrong terminology. You can use a break statement to kill the loop and stop whatever's in the loop. So like, let's say, for example, if I wanted to do something after this loop in my function, all I have to do is say print next step. That's the next thing I wanted to do. So I just have to put it on the same indentation, or sorry, same indentation as where the loop was. If I am done, let's say I only want this line of code to execute after this loop is done. So now it would print this once it's done. But if I had a break statement here, then what would happen is it would go, well, in my exact example, what would happen is it would print that the current character is I and then the little arrow, and it would do the W, and then it would stop, and then it would print next step. If we were to execute this function, it would look like this. It would look like this line, and then the next thing would just be next step, and it wouldn't do any of this nonsense down here. That's what would happen. One other thing about, and this is also true for while loops, by the way. One other thing about for loops and while loops, if you ever put a return in your code, like, I don't know, let's just return none, I guess. If you return something inside of a for loop or in a while loop while you're inside of a function, like how we are right now, we're kind of in both, it will kill not only the for loop, but also the while loop. So even though I have the next step thing there, it won't, sorry, there was something weird just happened outside. It won't actually print the next step. It won't say print next step. Like, it won't ever get to that point, because once it hits that first return, it's going to kill the entire function. It's just going to set the function equal to whatever that is and just move on. It doesn't even care about anything beyond this loop. Theoretically, if you had certain conditions, it could be possible for it to still keep doing this stuff as long as it never hit the return. If you have a return anywhere in your function, as soon as Python hits that return, your whole function's done. Like, it doesn't matter what you had after it. That's why if I were to put some other stuff here, like, I don't know, print other stuff, notice it highlights it gray in VS Code, because VS Code is smart enough to know, hey, you're an idiot, because that doesn't work, because we just hit a return. So this will never, ever fire off. Anyway, so that's returns. Returns are very helpful to know. You can use them like a break, but sometimes you want to break the loop and still keep going. And that's a good example of when to use a break versus when to use a return in that case. So anyway, okay, so that's how you convert between the two, and that's traversing by index. You don't have to know traversing by element. It will not be on the midterm. It says it in the PDF, but I just wanted to cover that. Real quick, let's just finish up the next thing about loops, and then we'll move on. So we've already talked about this. We've already talked about this. Building a string just means, okay, let's say we want to create a new string. So instead of just printing, let's say we want to have a new string, and it's equal to new string, and let's make it an empty string. What we could do is we could just say new string plus equals current character. And now our string is going to be equal to basically the output word. Once we finish the output word, well, let's not print it that way. Let's just print it as new string. But now, once we do this function, let's go ahead and call the function again real quick. Traverse by index word. So now, this should print out the WORD thing, but it should also print word once it's done. And it did, right there. And because that's what building a string is. That's what that line means. It means we're taking a string, could be an empty string, could not be an empty string, whatever, but we're building it, we're adding something new to it, and we are kind of creating a new string based on that. Now, this seems kind of pointless, like, okay, we already have the word here, why do I want to print it there? But you could do this with other things. So, I know that example seems kind of pointless, but just that's the most simplistic example of the idea that I can show you. In that particular example, it kind of doesn't make sense to do that, but whatever. Anyway, accumulating a sum, basically exactly the same thing, but instead of instead of a string, we're using a number here. So let's say example integer. Again, terrible variable names, guys. Please don't use these variable names. But anyway, so we could do the exact same thing, because notice I was an integer, so we could use that. So we could say, okay, how about example integer plus equals I, and then we could print example integer, and let's space it out so it's a little bit easier to see based on the indentation, like what's actually happening. So it's going to go through this loop, and it's going to keep adding numbers to this, and then once it gets to the end of the loop, we're going to also print that. So now let's go ahead and do the same thing. And if my math is right, we should get 6 from this if we call it with word again. So I guess I should have kept that. But it's literally the same exact thing. We should say word and then 6 instead of word and word. Yeah, right there. See? 6. There it is. So that's accumulating a sum. That's building a string. It just means it's kind of like your pig dice game where you added a dice roll number to it. So basically the same thing. Okay, moving on. Let's get rid of all this crap. We don't need any of this. Oh, goodness. Goodness. Okay. All right, we're pretty much almost done, actually, believe it or not, because all the other things I'm going to talk about, I've kind of already talked about to some extent. But let's go ahead and finish up here with the top bullet points, and then we'll move on to we already talked about indexing a string, so we can skip that. I just need to cover these 3 things real quick, and we're not going to cover them to their fullest extent, but I am going to cover them a little bit. Print and input I'm going to cover first, because that's like the simplest possible thing to cover out of those 3. So print takes an infinite number of arguments. So if I say print hi, and then hello, and then what's up, I can keep going with this forever. Now, when you add a comma in a print function call, you're giving it multiple arguments. And when you give print multiple arguments, it has what's known as a separator value. And this is a keyword argument that you can access. And it's by default, the separator value is always going to add a space between each string. But you could change this. You could say, I want these all to print on new lines. So it's going to say hi, and then a new line, and then hello. And let's just add a space at the end. And let's go ahead and execute that. So notice now it printed them all on new lines. But if we get rid of this part, it's just going to print them all spaced out. So watch what happens now. See, now it prints them all spaced out. That's what's known as the separator keyword argument in the print statement. Very, very simple. I know it might seem somewhat complicated, but it's very, very simple. You can give print any number of arguments, but if you put a comma between it and you don't change the separator argument, by default, it'll always put a space between anything you put a comma between. Okay. The input argument, on the other hand, is a little bit different. The input argument only takes one argument, or none. You don't necessarily have to put an argument in. If you don't put an argument in, it'll just kind of print a blank line right here, and it'll just keep blinking, and I just have to hit enter, and then it executes. But if I do give it an argument, it has to be a single thing, and generally it has to be a string. So you could say, please, whoops, I think I typoed, but I can't really see because my cursor's in the way. Please type your favorite number. And then I can go ahead and execute this, and I can say, yeah, my favorite number's 5. Sure, why not? And then we're done. But if I put a comma here, it's going to break. See, let's say, please type your favorite number and your favorite animal. Okay, sure, why not? Let's try to execute this. Oh, look at that. Got an error. Input expected at most 1 argument. It got 2 instead. Oh yeah, it's because we have a comma here. We're putting in multiple arguments into input. That's not how input works. So input only takes 1 argument. So one other thing about input real quick. Input always returns a string. So right here, even though we gave it 5, watch what happens. If I save that to a variable and I say user's favorite number is going to be equal to whatever that input was. If I print the type of user's favorite number, let's go ahead and print what their favorite number. Well, we don't have to print it because we're typing it in input, so you guys can see it. But let's go ahead and print what the type of that variable is. Watch what happens. If we run this code and I say 5 is my favorite number, why not? Hit enter. Look at that. It's a string. 5 is a string, which means I am basically, when I type that and hit enter, I'm basically saying user's favorite num is going to be equal to 5, like this string of 5. So I can't just say like 5 plus 10, because that'll break. like Python won't understand what I'm trying to do and it'll break. So remember that when users pass input into the user input function, into the input function, it will always return a string. So you have to use certain methods to kind of like convert that input to other things. But I'm not going to go too deep into that because I'll waste way too much time talking about that. We don't need to talk about that right now. But I just wanted to help you guys remember that. And that is on the midterm. That does actually, like, I don't know about the questions wise, but that does show up in this PDF is what I meant. So, okay. So let's go ahead and move on. We talked about print and input. Let's talk about evaluating arithmetic. So there's a couple different arithmetic things in Python. So there's operators. That's the word I was looking for. So there's different operators. There's the word in. There's the word is. There's these like equal signs. Like this means is it equal to something? Sorry, let me get rid of these words so you know what I'm talking about. The double equal means is something equal to that. So we could say A to B, and then it's like does A equal B, as opposed to A equals B, which is like, okay, A definitely does equal B. But the line above that is saying, does A equal B? I don't know. The next thing you can do is you can say, let's just keep our B here, because why not? You could say A is greater than or less than, sorry, not greater than or less, greater than or equal to B. You could say that A is less than or equal to B. You could say that A is greater than B, or you could say A is less than B. You could say A is B. That's a specific kind of word, and I don't think we ever cover that in this class. So you can look that up on your own time when your brain isn't fried from all the information I'm throwing at you. Just make a note of that and look it up later. Don't worry about it right now. But it's kind of like the equals equals, but not exactly the same. There is a difference. But anyway, we'll move on. But you could also say A in B, and this is actually a question, because we're not saying that A is in B. What we're saying is A in B? And you see this a lot in strings. So, for example, let's say I have my word string variable here, and we're going to call it equal to word. I want to know if there's a W in that string. So we could say, I don't know, W in word string. And this should print out true, I think, if I did my syntax correctly. True. There we go. See? Yeah, W is in string. Notice this is a question because it's a true or false. So like Python has to evaluate, it has to figure out, okay, is the substring inside of this string? And it says true. And let me get rid of the variable so you can see like literally what it's actually doing. It's literally saying, okay, is W in word? Yeah, true. See, it still prints true. So the in variable is used, or the in keyword in Python is used a lot if you're evaluating if a certain thing is in a bigger thing, like if a specific character or a substring, and you can use more than one character for this, by the way. I could have said WO in word, for example, but you're basically saying, is this smaller thing inside of this bigger thing? And this is true for strings, for lists, for tuples, dictionaries, all kinds of stuff. So it's a great thing to do. Please memorize this if you can, but don't memorize it for I don't think it'll be on the midterm, but just something to make a note of for your own notes. Definitely use it. So, those are your operators. You also have and you have or and not. And not just is like a negative sign like in math. It just kind of converts whatever it is. So if you say not true, then it's false. If you say not false, then it's true. And I could say not W in word. And if I printed this whole line, well, I have to actually use an actual literal because I don't have the variable anymore. But if I printed this line, it would say false because we know that W is in word. But I could say or O in word. And in this case, we know that W is in word and O is in word. But what if I use something here that wasn't in the word? Like what if I said P? Okay. So if P is in word, then true. So now we're talking about multiple things. So this part is true. So let's just go ahead and do that. Let's make a new line so I can show you visually what I'm doing here. So we know that the first part of this is true. Now let's have our or statement. Okay. So now when you evaluate the second part, is P in word? No, there's no letter P in the word word. So we know this is going to be false. Now, for those of you who have taken discrete math, you already know what this is going to turn out to. For those of you who have studied the truth tables, you already know what this is going to turn out to. And if you don't, that's okay. Just follow my example here. So when you have an or statement and you have a true or a false, it's always going to use the true statement. So we know that this is going to turn into true. And now we can get rid of our parentheses here. And now not true, well, that's just going to be equal to false. And that's how you evaluate that stuff. Very, very simple. Now, if this was an and, then these would both have to be true. So if these are both true, then this would be true. But since we know that this one isn't true, then we know the whole thing is going to evaluate to false. However, since we have a not here, since we know this turns into not false, well, what's not false? True. True isn't false. There you go. So look, now we have a true statement. So, this is kind of more like a high level, like conceptual thing. You don't really think about this until you're actually writing if statements. But that's how you evaluate that stuff. Very, very simple. Just break it down into small pieces and then evaluate it piece by piece and utilize parentheses, because where the parentheses are matters in these kinds of things. But I won't get into all that. We're wasting way too much time. We're already almost an hour in and we barely even covered like the first page, but we're actually almost done with most of the content though. Okay. Next thing I want to talk about is ifs versus elif. So we're going to move on to this example function that I made, and I'm going to uncomment this stuff out here in a second. But we're going to move on to this next example function that I made. And this function iterates through by element, if you remember the terminology for character and input string here. So we're saying if the character, so let's think about the example. So I have this example here where I called the function with test.123. So we have a string that's test.123. And we're trying to see if each letter is like a letter, or if it's like a number, or if it's not a letter or a number. So here's the thing. What I love about this example is this is exactly how if, elif, and else actually works. Because what we're saying is if some condition, mind you, by the way, every time you write an if statement, all you're ever actually telling Python is if whatever this condition is true, then do whatever's under the if statement. So what I want you to think about when you're writing Python, I want you to just like forget about all the crazy. When you look at all this at first glance, it's like, whoa, there's so much going on here. Don't worry about it. Break it down line by line and section by section. This part here on this if statement, it's saying I'm looking at the for loop. This part here on the if statement is saying if some condition, and this some condition is character.isAlpha. We haven't really gone over string methods, so I don't expect you guys to really know what this part is. But this is this is a way that you can get a string to say, like, this will return true. Like, this whole block of code right here will return true if the character is, like, a letter in the alphabet, basically. And this will return true if it's a number from, like, 0 to 9. And it only looks at one digit at a time. That's why it's 0 to 9. So, anyway, so basically what's going to happen is when we go through this thing, it's going to print, okay, the current letter is W. And then that's going to be true, and it's not going to do any of these. And then the current letter is O, current letter is D, or actually, what was our string? Oh, we're doing test. Okay, sorry. It would be T, and then E, and then S, and then T, and then dot would go down to the else, and then it would go 1, 2, 3. And that's how it's going to execute. It's going to execute this if statement 4 times, and it's going to do the else 1 more time, and then it's going to do the elif. But what I wanted to tell you is there's a difference between doing if and elif here. Because notice, I could do the same exact thing. Let's do the same thing. Let's just copy the code. Why not? I could do the same thing, but I could just make this a bunch of ifs. And I could say if not character is alpha, or character is digit. Hey, look, we use that exact example like I showed you below where we were talking about the not and then the parentheses. How funny. I just told you might not see this in your actual code, but here we are. We're doing it right there. So there's a difference between these two. Even though they'll both actually end up printing the same thing, there's a difference because the way Python executes these are completely different. So the difference between an if versus an elif, when you have a second if on the same line, the difference is Python, once Python, like let's take this function for example. When Python executes this function, what's going to happen is it's going to check and it's going to say, okay, T is a letter. Okay, do whatever this is. Once it does that, it's not even going to give a crap about what's under here, unless there's another if somewhere. Then, like in this function, it would print, okay, current letter is T. Then the difference is, on this time when we call the function, it is going to check all of these, even though it doesn't need to, because T can't be both a letter and a number at the same time, and it certainly can't be either or like, sorry, it can't be neither of them. It has to be one or the other or neither. Like, it can't literally be both of any of these combinations. So it doesn't make sense to use a bunch of ifs here. Whereas if we do this example, this makes perfect sense, because in our current example, yeah, our character could be a letter, but it definitely couldn't be a number at the same time. It definitely couldn't be an else. But there are valid examples as to when you'd want to use multiple ifs like this. And the example of when to do that would be, take my nature photo thing, for example, again. Remember, I told you there was different criterias for the photos that we needed to check. We needed to check the file size. We needed to check if it was a duplicate post or not, if we've already posted it before. There was other things like we hashed the image, which would help with the duplicates. We also checked our post ID on the service that we were getting the posts from, because we were using photos from Pexels, and Pexels is kind of similar to Facebook in that it has post IDs, and then we can check the post ID because we store the post IDs in a database. So in those examples, what I'm trying to say is those were completely different criteria. Like, a photo could be perfect in every criteria, but not meet the file size criteria. So we kind of have like a checklist. It's like, okay, check, 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 check. In those examples, then you would use a series of ifs in that case, like conceptually, maybe not exactly how you would actually code it, because that might not be the most efficient way to do it. But theoretically, that's how you would do it, like in theory, in terms of this kind of example. So if we were checking if the character was a letter, like actually an alpha, like not alphanumeric, but if it was an alpha letter, A through Z, we could also check if the letter was a certain kind of letter, or we could check if maybe the letter has shown up again already. Like, maybe we're keeping account of how many letters are in the string. Like, for example, the word test has 2 T's in it. So maybe we have like a variable, maybe we have like a dictionary object that counts how many times we see each letter, and anytime we see a letter we haven't seen before, we'll add it to like the dictionary. But we haven't covered dictionaries yet, so don't worry about that. But you could have like different criteria, and that's when it would be fine to use other ifs. But computationally, this doesn't make sense, because in this exact example, these things they can't all be the same. So that's when you would use an if versus an elif versus like all that. And by the way, else catches anything that the if didn't catch. So in this case, this particular line will execute because of the dot. But if I didn't have the dot, this line would never actually execute. I mean, Python will still check it. If the ifs aren't true, it'll still check it. But because we have the else, Python will just say, okay, do whatever else was a thing, because this wasn't a thing. You see else a lot in user input, or in places where we don't always know what our data could turn into. But we do want to do something with our data if it meets a certain criteria, but we don't necessarily want to do anything with it if it's something else. But we still want to control for those scenarios. We don't just want to not do anything sometimes. Oh, excuse me. We don't just want to not do anything. We want to do something. We just don't know what we want to do specifically, because we don't know what this thing is. So that's a good example of when to use an else. In this case, we're controlling for a character that's not a letter or a number. Say we're going to do some fancy magic here. I don't have any magic that does anything to symbols. So like, I guess we'll just say it's not a letter or a number. Can't do anything. So that's what else does. It does everything that these two didn't do. Even if you just have one if, it does everything that the if didn't do. Now, note about elif. Elif stands for else if, and you can't have an elif by itself. If I comment this line, Python will yell at me. Watch this. Python's so mad. Look at it. It's just fuming right now. Look at him raging, dude. What a rager, bro. So if I get rid of this, it's fine. But if I do that again, look, Python's mad again. What a freaking nerd. Look at that guy. He's so mad. So anyway, yeah. You can't have an elif without an if. You have to have at least one if on the same indentation above an elif. Otherwise, it kind of breaks everything. It really pisses Python off. If you want to make Python mad, there you go. Easy way. Easy way to do it. Okay, let's move on. That was everything I needed to cover in the whole top of this PDF. I'm not really going to go over this stuff because this is pretty straightforward. The only thing I wanted to mention is this is integer division. So if I do like 3 divided by 1. Well, that's not a good example. Let's do like 6 divided by 3. Then this would be 2. But if I did like 5 divided by 3, then this would be like 2.66666 repeating. But if I just did 5 double divide, like integer division by 3, then this would be 2. Even though it's not actually 2, but it's 2 point something, and we don't care about the point something. We just care about what the number was. And this is good for if you're doing something where you don't actually care what the decimal is. You just want to know what the closest, what the lowest like possible number it could possibly be is, without actually like, that can still go into it, but maybe not the full thing. So that's a good example. And then likewise, if you kind of wanted to do the opposite of that, where you do actually care what the remainder was, and you want to know what it was as an integer, this up here would give you 2. But maybe this isn't the best example. Hang on. Let's do this. So, wait, what am I doing? 5 divided by 3 would be 1. What am I talking about? If that was... What am I doing? I didn't pass kindergarten, guys. I lied earlier. I didn't pass kindergarten, apparently. This would be 1. I'm sorry. I'm an idiot. This would be 1, but this would be 2. Sorry. Goodness. And a major tickle in my throat there. So, what this does, this percent sign, is known as the modulus operator, and it gives you the remainder. So 5 divided by 3 is 1 with a remainder of 2 left over, where we almost got a 3 again, but we weren't quite there. We were 1 off. So we had a remainder of 2. So this gives us the 1. This is the remainder. So they're kind of like opposites in that regard, but like 2 sides of the same coin, essentially. Okay, we're not going to go over PEMDAS because that's kind of just a general algebra thing, but just keep in mind what it, like how it, I'll just have you read the PDF here because it does actually explain it pretty well, and I don't want to waste your guys' time with another 2 hours of lecturing. Okay, we kind of went over all this stuff. Oh, we didn't go over the not true thing. Okay, I'm so sorry. I forgot about this earlier. So, if you say A exclamation point equals B, what you're saying is A does not equal B. And this can be a question too. Like you can say, well, it's not ever really a question, but you could say like, if A does not equal B, then do something, because you may not necessarily know. But you can use it as a statement to put into if statements to kind of turn it into a question. But that's basically what it does. It's kind of like the opposite of the equals equals. So it's like, it's basically saying A does not equal B, basically, instead of A could equal B. So anyway, moving on. We kind of already talked about all this stuff. Yeah. Boolean stuff will always evaluate to true or false. There is one more Boolean thing I wanted to talk about, but I don't know if we'll have enough time, because I'm trying to look through the rest, see what we haven't covered. I want to kind of skip some stuff, because we did already talk about this. Like, for example, we already talked about the, not, and, or stuff. We also talked about Boolean expressions can exist without necessarily using an if statement. I already proved this with the in thing when I was talking about W in word. We kind of already proved that. Remember, it printed true without an if statement. So we kind of already talked about that. So I'm going to kind of move on. Know what happens when a value is a condition. It's in a condition. Okay. I think we have enough time because I have a reason to talk about this now. So I'm going to super quickly cover this because we've already been going on for an hour now, and I have a lot to talk about. But we are almost done, actually. There's a lot of stuff that I've already covered. But I do want to talk about this real quick. So, every variable in Python, well, maybe not every variable specifically, but every built-in data type in Python has what's known as a bool method, or a length method. And this method allows us to evaluate whether it's true or false. And every built-in data type, like strings, integers, floats, booleans themselves, obviously, lists is what I meant to say, dictionaries, tuples, sets, frozen sets, all these things, they all have the ability to evaluate whether they are true or false. And I'll show you. Watch what happens. If we use this bool function here, we can get whether it's true or false based on that. So let's go ahead and pass in an object here. Now the bool function returns stuff, so we have to print its value. So let's go ahead and print. So, sorry. So let's actually, you know what? Let's make it a variable, and let's say x is equal to 5. Okay. So let's print what x is evaluated to, because x is 5. Like, is x true or false? That doesn't make any sense. X is 5. It's not a Boolean variable. Well, guess what? We can still evaluate it. Check this out. If we print this, it should print true. Oh yeah, and it printed all the debug stuff that I was talking about. I wanted to cover debugging. I'm not sure if I have enough time. So we're not going to worry about it. Also, I'm going to remove this. So we don't need to worry about that anymore. And I'm just going to comment this line out so it doesn't mess with our print statements. So now, let's just clear this crap out. So now, if we run this, see, it printed true. That was our print statement right there. True. But why did it print true? Aha. Aha. So here's what I was going to say. Everything in Python, when it comes to the built-in objects, like strings, lists, tuples, and dictionaries, and so forth, those specific kinds of objects are what's known as iterable objects, which means we can iterate through them. So I can make a for loop and go through each item in that thing. So like I could get each character in the string, I could get each item in a list, I could get each item in a dictionary, whatever. A lot of these we haven't talked about yet, but think about strings. I can get each character in a string. So that's what's known as an iterable item. Iterables will always evaluate to true if they are not empty. So for example, if x was an empty string here, let's go ahead and redefine x, and let's just kill this line. There we go. So it's not too confusing. It would have worked without killing that line, but I want to fully show you guys. So now notice it's false because it's empty. Okay, that makes sense. But now if we add in something to this string, let's just add in a dot, for example. Now it's not an empty string anymore. It has a dot in there. Watch what happens. Boom, now it's true. This is true of strings, iterables of any kind, which also includes lists, tuples, dictionaries, and sets, and so on and so forth. However, numeric data types like integers and floating point numbers, like 5 and 5.0, which is a float now, but these data types will always evaluate to true if they are not 0. So we've already did this, but let's go ahead and show you. If I print x is equal to 5 and then print the Boolean value of that, that's true. But watch what happens. If I change x to 0, it's false. Also, if I convert x to a float and I say 0.0, also false. But if I do 0.1, it's not false, it's true. See? Right there. So, boom. Easy peasy. Easy peasy. Now, where this comes in handy is, I know this seems like one of those really weird things. It's like, why am I even talking about this? This seems like such a niche thing. Let me tell you, I use this every single day. Every single day. I swear to God, I use this every day in Python. The reason this is so helpful to know is I work with lists a lot, and I work with iterables a lot. A lot of my work generally comes with lists and dictionaries and things like that. So I need to know if these things are empty, because there are certain sections of my code, when I'm writing my code personally, there's certain sections of my code where I'm like, okay, I want you to go through this list and I want you to get like the 17th item or whatever, and then do some stuff with the 17th item. But the thing is, if we try to like index a thing that doesn't exist, like say for example, if I say, let's get rid of our print bool thing. By the way, the bool is how you evaluate stuff to true or false, but you could literally just do this. Like, let me show you before I move on. I don't mean to get too distracted here, but let me show you. I could just say if x, then print x, and then it'll print 5 to the console. So see, there we go. And that's what if x means. It means that if x is true, then do stuff. But anyway, let me show you what I was talking about before. So let's say we have a string here. Let's just say word string is equal to word. And then let's say I want to index that. Whoops, I accidentally typed a quote there somewhere. Let's say I want to index that. So let's say we want to say print word string and then like 3. That should give us D, I think, if my math is right. So there we go, print a D. But here's the thing. I also want to print like a thing that doesn't exist. So here's the thing. If I want to, like, or actually, you know what? Let's not do index out of range. Let's do a different kind of error. So if I want to do this, that's fine. But what if somewhere in my code, word string got redefined itself to an empty string? Well, now I'm going to get an index out of range error. See? Index out of range right there. So what if I had an if statement that could control for scenarios like that? What if I said if word string, then print word string 3? And maybe also you might want to say like if word string and length of word string is like greater than 3 or something. I don't know, just for the sake of, or like greater than or equal to, I guess. I don't know, whatever, you know what I mean. Anyway, you might want to add another if statement there for that particular scenario. But yeah, I could just say that, and now watch what happens. It's not going to print anything because okay, word string was false. So, okay, since word string is an empty string, let's not do something. That's what I want to show you guys. That's what's so helpful. It's so helpful. I swear to God, I use this every single day. So helpful. I swear. So, let's move on. I've pretty much covered almost everything. Let's see if there was anything I didn't cover. We talked about the length function. I kind of showed you when I was doing stuff. Length will just return however many numbers of characters there are in the string, if you're using it for strings. String literals are always enclosed in quotes. The literals means like this. It means I'm literally typing a string directly into Python. That's what the literals means. Okay. Make sure you differentiate between a variable and a literal. Again, a variable would be like, for example, word string is equal to word. So this is a literal. This is a variable. That's it. Pretty easy. Easy stuff. Okay. We talked about input, \n. This creates a new line. This creates a tab indent. You can use them in strings like this. \n right there. That will create a new line at the end of that print statement, which print already does that, but it would make another new line at that point. And then you could use a tab here, and that would make a tab, and then print will also add a new line as well by default. So it would have a tab space, and then it would print a new line. And a tab is just 4 spaces. So, yeah. Anyway, but you can use that. You can also, by the way, people don't know this, but you can also use this for quotes as well. So I can add this. It's kind of hard because my cursor is kind of blocking, but I could put quotes around my character. I could say current letter is, and then I think I called it with test 1, 2, 3 down here. I kind of commented it out, but it would put like quote T quote at the end of that part. So those are known as escape characters. So anyway, moving on. We're going to fire through the rest of this so we can be done. Typecasting functions, how to use them. Yeah, that's the typecasting functions are, if I remember correctly, let's not tell you guys the wrong thing. Let's look this up. Typecasting in Python. Typecasting functions in Python specifically. Yeah, that's what I thought. It's the functions that convert the function or convert variables. So I could say like example string of 5 is going to be equal to 5, and then I could say float 5, and that would make it 5.0 basically, and then I could say int 5, and that would make it 5, which it would turn into that literally, and then I could say like int, I don't know, int string whatever. So you can put multiple of these, and you could say what is this? Oh, crap. Okay. I have a meeting that I have to go to. Crap. Okay. Hang on, guys. I think we pretty much covered everything, though. Let me just look through real quick. I have a meeting that starts in 10 minutes, but we're already at the end of the PDF, so I think we have pretty much covered everything. So understand how print works. It can take multiple arguments. You can use concatenating. You can multiply string variables. Blah, blah, blah. We kind of covered all this stuff. Print and return. We already talked about the difference between print and return. Print just prints it out to the console like this, but return actually sets your function call equal to whatever it is that you returned. We didn't really cover random, but I'll cover that real quick. I think that might be the last thing. Be able to define specific parts of the function. Yep, see, I already talked about this. Scope. Yep. Scope. We talked about scope at the beginning of the video. There's the loops. Okay. You don't need to know nested loops, string methods, slicing, traversing by element, none of that. know when to use while loop. If you use while loop, or sorry, not while loop. If you use while true in a loop, you have to use a return statement or you have to use a break. Otherwise, the loop will never end. So if you're in a function, you just have to make sure that you use a break or a return. Otherwise, your loop will never actually end. So just keep that in mind. I like to use while true a lot in my own personal coding because it's just like easier for most of the things that I do. But there are definitely more valid options. I kind of skipped the whole page. Sorry. Know how to use a loop to update a variable. Yep, we kind of talked about that already. I'll let you figure out what weird is. I'll leave that as an exercise to the reader because I don't have much time. You should be able to look at a loop and know what it's doing. Yep. Know what a string variable indexed by an integer evaluates to. Yep, we talked about this. This would be 1, 2, 3. This would be lowercase e, by the way. What does the above print? Yeah, we just said that. Know what the for and while loop control variables are. The control variables are what's known as these things. This character here, and this I here, and this I here, and this character here. They're all control variables, and they control when the loop will stop. Because in a for loop, when the I reaches the final thing that it was iterating through, and it can't be anything else, when the I can't be defined as anything else, then it's going to stop. So, like, for example, if I were to traverse through the word, I would first be equal to W, then it would, well, first it would actually be 0, because if we're doing it by index. But it would be 0 for W, and then 1 for O, and then R for, or 3 for R, and then, or 2 for R, and then 3 for D. And then on the fourth iteration, when I is 3, it would loop to the next iteration, and then it would say, well, I can't be anything else, so it'll stop. And this is also our control variable here for the while loops. Kind of the same thing. Know how to convert for loops and while loops. Oh, know how to traverse accessing elements. Okay, know how to use while. Okay, we just did that. Awesome. Okay, we're done. All right, I gotta go, guys. I hope this was super helpful. I'm so sorry I didn't get to do this longer. I gotta go have a meeting in 7 minutes. I'll see you guys later. If you have any questions, please feel free to comment below, message me, email me, whatever. I don't know. Whatever gets a hold of me fastest, I don't care. I probably won't check the comments, to be honest. I mean, I might, but I won't be all that quick about it. But if you do message me on Slack or email me or something, that's a lot easier if you're in my class. Otherwise, yeah, thanks for watching, guys. Sorry if this seemed a little rushed. I didn't have a whole lot of time. But I hope that was helpful. Good luck on the midterm. You guys got this. If you need help, just rewatch certain sections of this. It'll make this easier to understand, hopefully. If not, just look it up on Google, look up these terms, whatever you need to do. I don't care. Or just ask me. Okay, well, I'll see you guys later. Thanks for watching. Good luck. Bye.